Welcome. My name is Zachary Markin. I run HT Developers, which is a technology-first consultancy focused on the healthcare industry. Primarily, we serve healthcare clients in the United States. We build all kinds of custom software, a lot of mobile applications, a lot of analytics and data warehousing, as well as more sophisticated infrastructure and technology backend systems as well. Although previously I was an engineer, I'm not an engineer today, but this talk will be share a little bit about both the technical direction that we're taking in this company, as well as share some of a client that we work with, and a nice example of the ways that the technology we're building can improve health and improve the quality of life in the world. So with that, I'll just move on a little bit. I just told you about HT Developers. So our client mix is a mix of what we call digital health startups, and technology is really transforming medicine in general in the United States in a variety of ways, and also across the world. The most interesting ideas come from a unique blend of technology innovation, healthcare products, and business model innovation as well. So about this talk, today we're going to talk a little bit about how we're using machine learning to impact health and impact wellness in society. I'll share a little bit of information about us as a company, and also some information and opportunities. So just to give a quick shout out to the team of scientists who we work with on this work. They're based at the University of Pennsylvania, which is an Ivy League university located in Philadelphia. And specifically, Dr. Brenda Curtis and Salvatore Giorgi, who work with one of our clients, SoberGrid. So before I talk about the technology, let's just talking a little bit about the concept of addiction and drug abuse in general. This is a massive problem. Addiction destroys lives, it breaks families, and it destroys communities as well. Just to a little bit of statistics, right now in the United States, there's a opioid epidemic happening. So these are drugs like heroin, fentanyl. In 2015, there were 52,000 deaths due to overdose. It's a pretty massive problem in scale. In 2012, there were 260 million prescriptions, and it's a extremely expensive problem as well. And I'll get to the technology in just a moment. I know you're probably more eager for that, but just to give a little context, so these are some headlines recently. This fire department responds to more overdoses than fires. Opioid crisis forces grandparents to raise their grandchildren. Overdose crisis claims 7 lives per week in Vancouver. Here's a picture of some parents who have overdosed in a vehicle while their young son is in the back seat. So this is all connected to an evolving view of health and wellness. So if you look at basically the science and the medicine are moving together in a way that's unlocking amazing potential for new technologies, then care is moving out of the hospital into people's lives in general. And a lot of that is happening on mobile devices, and just like the products, consumer products that you're used to, the different data and analytics that, and the user interaction with those consumer products unlocks amazing potential for machine learning to, drive impact in society. That's happening in healthcare too. And so, just to talk very quickly about healthcare in general. So this plot represents kind of the main drivers of health outcomes. So a health outcome is basically how successful healthcare is for an individual. So 40% of what determines how healthy someone is are behaviors. So these are things like, do you smoke? Do you exercise? 15%, this red, are social circumstances. So these are things like who your friends are, what your housing is like. Environment is 5%. That's how clean is the air and water. 30% is genetics. So this is like kind of the lottery at birth that determines how healthy you are. And then only 10%, that this little purple triangle here on the top, is the actual care you receive in the hospital. And so all of that trend basically is forcing new ways of thinking about how to give healthcare and how to care for individuals. And the result of that massive paradigm shift in that massive industry is that there's amazing potential for building technologies into people's lives to help care for them, because everything that isn't purple here, well, maybe everything that isn't purple and green here, and I apologize for the coloring on the screen, but at least this whole right side of it are things that are in people's normal lives. And so that's where mobile devices and mobile technologies in healthcare are starting to play a very important role and solve some of the problems that previously haven't been possible to easily solve. So a little bit of vocabulary before getting into the project work here. So the word when I say sober or sobriety, what I'm referring to is an individual not using drugs. So this is someone who was addicted to drugs or alcohol. If you stop using drugs and alcohol, then you're a sober individual, or you're in a state of sobriety. Relapse, when I say relapse, what I'm referring to is if an individual who is sober starts taking drugs again. And so a poor outcome would be that if you're sober and you're trying to become sober, and you're staying sober, but then you start using drugs again, that's a really bad thing to happen. And then when I say cohorts, this is like traditional cohorting from modern data science and web technologies. So this is defining groups of users who are considered similar. So you might cohort based on demographics, you might cohort based on time since engaging with your application, and all of that drives, those cohorts are the foundation of the data science and the machine learning that you apply. So SoberGrid is a mobile technology. It's a bit like Facebook. It's a social network for individuals who are staying sober, who have previously been addicted. So on that community, individuals might have a profile. They might make posts or status. They might comment on other status. They might engage with their friends. And so all of those actions and interfacing with the application are a foundation of different types of data that users engage with the app. And so some of that data is naturally structured because it's, say, part of their profile. Other data, like free-form text, for example, is unstructured. And so a lot of what you do in a machine learning and analytics capacity is to try to move data from being unstructured to structured. So our firm started working with SoberGrid as they began to achieve success. They scaled very quickly. Their products started breaking. We rebuilt their infrastructure with a lot of Ruby on Rails technology, but also some other microservices supporting the production application, feature development, as well as strategy and direction. So there's two machine learning applications that are taking place in the SoberGrid. So the first is predictive analytics based on natural language processing. So how can we predict relapse? So that's an individual moving from a state of sobriety, moving to a state of drug use. How can we predict that before it happens? And then the other one is bringing sort of modern A/B testing techniques to clinical therapies to treat this. Does everyone know what I mean when I say A/B testing? This is you should be familiar with it from other consumer products. Talking a little bit about the supervised machine learning going on at SoberGrid. So basically you have a production application that has a set of data inside of it through an extraction. So there's an extraction pipeline followed by some analytics code, and then followed by your actual machine learning pipeline. And so basically, the structuring data, the structuring process identifies fields that we already have that are structured. So these are things like date of sobriety. So a very important part of a user's profile in that product is the last time they used a drug or alcohol. And so if an individual relapses, they might reset that date of sobriety. And so at scale, over 50,000 or 70,000 users, that provides a very interesting data set because we know dates at which users went from sober to not sober. And the result of that is that we're able to match that with other data in the application, such as what they're writing, what they're messaging to other users at that time, and that provides a foundation for a supervised machine learning. So the interesting thing is the actual machine learning that takes place is not terribly complex. We're really curve fitting, so the end result is basically a polynomial, and so to give a little bit of background, so that basically in a supervised machine learning context, you dimensionalize your population. In this example, there's two-dimensionality shown, but really, you add many, so it becomes a polynomial of say 10 or 12 or 15. You create this dimensionality, and then each one of those axes might have some impact on predicting a user's relative state. And so the question we're asking and answering is, in any given week, based on what a user is saying within the application, are they more likely to relapse that week? And the end goal is to predict that relapse before it happens, and in the long run, build features into the application where someone who is an actual medical care professional at that point can do an intervention and prevent that person from relapsing. And so conceptually, that has all of the same challenges that other machine learning applications in consumer tech have. So if you think about like challenges of creating, say, a spam filter or something like that, if you mark a user's email as spam when it's not spam, they're going to be upset. If you send a healthcare professional to someone's house because you predict that they might relapse, but they really won't relapse, they may or may not be upset, but you've certainly wasted resources when you do that. And so we have all of the same problems from consumer tech, except we're applying them in a healthcare context, which just has a whole unique set of problems, challenges, and also really amazing opportunity. So just to talk a little bit more about the techniques used. So the traditional, I guess I'll go back here. So the tokenized, the structured language is the sobriety date, and then we use a tokenization process on the natural language to add structure to that as well, so that you can apply the structured sobriety data is your outcomes, and the natural language is your independent variables. And so by tokenizing that and creating those two distinct structured data sets, that forms the basis of your training data. And so just to give a very brief background of the kind of analysis we're doing. So the classic, very simplistic techniques for building structured data from natural language is to simply count words. So you might take the words that a user, that from a corpus or a body of text, find all of those that are unique and count their occurrence. And then in the literature over the past really 50 years, people have created, researchers have prepared what they call a lexicon. And a lexicon is a group of similar words that carry some similar semantics with them. So you may have a body lexicon, which has words like hand, head, foot, arm. You might have a conflict lexicon, which has words like mobilization, bomb, yell, treaty, arm. Interestingly, I point out just that the same token can be part of multiple lexicons. So there's a lot more complexity here than simply what you see. In addition to single tokens, we also use something called n-grams. So an n-gram is a sequence of tokens. So n is the number of items in that sequence. So a 1 gram would be 1 token, a 2 gram would be 2 tokens, a 3 gram would be 3 tokens. This is commonly called the linguistic inquiry and word count system. That's the traditional approach, and then the researchers we're working with, of course, do that as a baseline, but we also do something called differential language analysis. So differential language analysis uses tokenized language in the same way, except rather than so those analyses are what are known as closed language analyses. So that's basically saying take the language and put it into these closed buckets, and that it gives you some characteristics and ways to think about the language in use. A differential language analysis takes those tokenized language and creates it as a function of other known parameters, so age, gender, personality. So as a function of dimensionalized characteristics of your users, how is their language mapping to those different lexicons? One of the main areas that we use are lexicons that predict psychosocial traits. So this is a very commonly accepted framework for parameterizing an individual's psychology and psychiatric state. So these are things like extroversion, so how outgoing or talkative someone is, how agreeable someone is, how conscientious someone is, how neurotic someone is, and how open someone is. And based on language, you can identify someone's current state, both and this might be reflective of their natural character, who they are as an individual, but it also might reflect where they are at a given moment. And so someone who you imagine, so the really interesting thing about data science is you have this theory, but then what you need is also a theory of change for the physical world that you're trying to impact. So in the case of addiction, you work with people who study addiction, and you think about what is an individual like as they're going through the stages of sobriety and then subsequently relapse. So what happens to you if you're addicted to alcohol, say, and maybe you go home, you're living in a different place, but you go home to your families for the holidays, and all of your old friends and family around you are partying and drinking. You may find that your mood changes. You may find that you become, if you've ever spent time with someone who stopped smoking, you may find that person is a lot less pleasant to be around during that time. And so that's reflected in these big five. And so what you can do in the application is based on the natural language that's happening, you can develop an idea of where they are at that time and predict impact. These are some just a couple visualizations of different lexicons that were found to be more predictive of a case of relapse. So you can read into these what you want or not, but these are a lot more negative words. So like didn't, doesn't, wasn't. Hasn't, and then also this looks like some the machines do really strange things that you don't predict. So this is a unique combination of negatives and also masculine. So this also has brother, dads, he's, BF, which in English stands for boyfriend. And so somehow the machines identified these different buckets. This is another one that's this is you can get as existential as you like, but this has Steelers, Packers. Those are professional football teams in the United States, but also. Like Super Bowl is a big football game, but interesting also excited, powers, stoked. That's another slang word for very excited. So this is like a mix of superlative, but also contest. So you can think about that dimensionality however you like. So the next steps for that project are to validate ability to predict change in sobriety dates. Right now we're seeing some encouraging results, but if you want to actually achieve like clinical impact, you need to be very precise because you remember you're actually going in and doing something to someone's healthcare. So it's not the same as showing them on another product that they may like. If they, it's very different from if you're on Amazon and you've ordered one thing and it says maybe you'd like to order another. This is changing an individual's actual healthcare. It could have impacts for what medication they're taking. It could have impacts for what their family is thinking. But we also want to incorporate the models and expand them to incorporate measures of health in sobriety. So not just how sober you are or if you changed from sober to not sober, but how happy and healthy you are at any given time. And so an individual might be remaining sober, say they were addicted to alcohol, but their health may be declining in other ways. And then finally prepare intervention strategies with other medical professionals. And all of that is linked to kind of holistic business and technology strategy for the companies in general. So those final interventions, you need to develop new business models and payment methods to do that. So maybe you would be working with an insurer or a healthcare provider to fully close a circle. And so it's just a very different world from one where you build consumer tech and show advertisements, or where you try to convert users and get them to finish a transaction. So we just think about success in a totally different way. And frankly, you need to be. It's a space where technology is the table stakes. It's necessary but not sufficient condition for success. So now I'm going to talk about the other project that we're doing at SoberGrid. So this is bringing modern techniques of A/B testing and data-driven product development to the health and wellness and world of sobriety. How can you make product choices that achieve the best result? So just really high level. Generally, when you think about A/B testing, you identify success metrics, you release simultaneous versions of a product, you compare results that happen based on what happens in your user ecosystem and your product ecosystem, and then validate statistical significance and implement changes. So just to visualize that, you may have two different versions of your product. You split your users into two cohorts. So each of those 50% would be cohorts. This is a really simplistic model. If you only wanted to test a single thing, your cohorting model is very easy. You just say, oh, well, change them in half and give one half this and another half that. If you want to test multiple things, or you think about your users in different ways, your whole cohorting process becomes a lot more sophisticated and complicated. So we have really unique challenges both around cohorting, but also around the tooling and the infrastructure to build out and identify those cohorts. And then, in a broad sense, we're building a living clinical laboratory that's based on that. And so the thing is in addiction treatment, there's a lot of different theories about how how addiction works, what drives addiction. But there's a pretty limited it's very hard to do a clinical trial. They take years, they take tons of money and resources. And so the amazing thing about having a consumer style product is, just like at Facebook or other consumer tech companies where you can do data science all the time actively, you can do that too. And you can compare it to the sobriety. So, user sign up or user engagement with the product. We engage in dimensionalizing those users, so thinking about what characteristics are influential. So those might be sobriety, they might be age, they might be other scientific predictors. The result of that is real-time cohorting. So based on those 10 or 12 different dimensions that we're using, preparing these real-time cohorts for analysis. And then once you have those cohorts, you want to think very carefully about how you use them, because even the application which has had great success, has roughly 100,000 users. That's actually not as many as you think about once you start parsing them and slicing and preparing these complex cohorts. And just like if you're doing, the A/B test I showed at the very beginning is a bivariate. There's two options. But let's say you want to think about 3 or 4 or 5 different types of treatment. One might be a treatment that has users engage in mindfulness activities. Another might be a treatment that's purely education-based, showing a user how addiction works. Another one might be a treatment that another type of intervention. And so as you take those, as you add the number of variates into your system, you have to do true design of experiment and think about how not only the impact of any one of those things, but also if there's complex effects. So how one campaign might influence another. And so scientists have never had a real-time analysis infrastructure for doing that. And so the medical clinicians that we're talking to are very excited about this, because what they'll be able to do is they'll have a custom content management system for themselves. They'll be able to design therapeutic campaigns. If you come from a consumer tech world where you're used to, say, drip marketing, where you identify a user and you show them a relevant piece of content once, then in a couple days another time, and a couple days another time. Those are what are known as marketing touches, but you might also think of clinical touches. And so those clinical and therapeutic campaigns deliver content over and over again in the same vein. And then you also need to measure engagement with that. So is a user actually completing the exercise? Are they taking in the information? And all of that, I guess maybe the theme of this talk is that all of those actions are the traditional consumer tech actions, except they create structured data, which lets you do data science in a medical context in the same way that you could in another context. So that therapeutic, does that include question time as well? Okay. That therapeutic campaign, you do validation on those therapeutic campaigns. Ideally, those improve sobriety outcomes, so people are healthier, happier. And then you can actually modify the application and introduce changes in real time. And then that becomes a new baseline for your clinical laboratory. And so if you take away one thing from this talk, what I want you to take away is that at HT Developers, you have an opportunity to apply these technology concepts that are changing every aspect of our lives in the consumer world to really meaningful problems like keeping people healthy and sober. And then the circle continues, and just like any other technology product, it's iterative and collaborative. Just to very briefly talk a little bit about the kinds of work that sit behind this, there's tooling that needs to be built for this. So how do you in real time cohort users and create these groups of users? You need to build content management systems that lets non-technical users who don't know how to use the command line, say, don't know how to query your database, but you need to render to them information about the user base, but at the same time let them engage in a clinical context that understand it. And then also tooling for delivering that content over a period of time. There's non-technical work like content generation, so that's working with experts and researchers in addiction and relapse to create content campaigns that are relevant for that kind of work. There's scientific validation, so that's looking at the results of what's happening, proving that these different interventions are actually having impact. And then you have results, which are health, happiness, and hopefully more work for us. So just to give you a little bit of background of HT Developers, our company is 2 years old. Every 6 months since we began, we've achieved 300% growth. Today, the number of people in the company is just about 33. There's some are not quite full time. But around there. We have excellence in healthcare and great relationships in the United States, which let us unlock really interesting work. Our mission is to improve patient outcomes for every dollar spent. So basically, more cheaply, how can we keep people healthier and happier? And our principles as an organization are to apply a rigorous agile practice, achieve quality work all around, and respect for each other in the work that we're doing. So our colleagues are family. Here we are at a retreat in Italy, and then engaging in a fun VR game. Some examples of the kind of work we do. On the left here is a product called Agathos, which is we've built data warehousing, data pipelines, reporting tools, and basically what that does is it plugs into a hospital's health record systems and quantifies in ways for the individuals in the hospital how they're doing so they can improve the kind of care that they're delivering and improve the outcomes of the patients there. Beam is sexual health and transparency, so keeping people from getting and transmitting diseases as they date. This other one is called Crisis Care. That was produced with a teaching hospital affiliated with Harvard University. That's focused on preventing suicides in teens and adolescents. So if a teenager is discharged from the hospital, they're given this application. The application has content they can engage with and a content management system for the clinicians to update that. But it also has real-time essentially surveillance of the user but it's surveillance for their care team. And so if you see a teen is reaching for help many times, there's an opportunity to engage with that individual and prevent a horrible event before it occurs. There's some of the work that I talked about with SoberGrid could conceivably be applied to that world as it scales. This one is an application called Nutrimity, which is it's actually a mix of telemedicine and social network. So it helps mothers live healthier lives when they're pregnant, but it's really focused on diet. And so at any time, a mother can have a telemedicine visit with a nutrition expert or a registered dietitian, and that engagement can lead to better outcomes at birth and healthier, smarter, happier children. So we have 10 minutes left. So at this time, if there's any questions, I'm happy to field those. And we're also giving mugs to this gentleman and those who ask questions.
So hi. So the question is, oh, thank you. So the question is, when you're doing antagonization of language, you're kind of flattening out the personality of a person. And I don't know if you saw this article that kind of made its headlines with the photos of people that had depression and then committed suicide. So the question is how, because what they looked like happy. So if we're getting this subset of a personality, you know, what about false positives?
Yeah. So great question. And so that question really gets at kind of the core nature of this work and why it's really hard. So that was an example I gave in the talk as well, right? So like if you have a false positive where you identify a message that's spam that as not spam, or a message that is not spam and you call it spam, that would be a false positive, but the impact is pretty low. If you identify someone who is, you say this person's at risk of relapse, go to their house right now, and it turns out that actually, their cousin was playing with the phone and putting in messages. You might have just wasted a lot of money and effort, and your client, who's a hospital, might be pretty mad at you for doing that. And so that's why it's so important to make sure that you're doing this work at scale, and you're tracking these clinical outcomes at scale. And that is the nature of population health in general, is that in any statistical analysis, that for any discrete sample within your population, there's some uncertainty and some variance, and hopefully what you do is the positive outcome of your intervention pays off enough. So if you prevent one person from relapsing, that might save the health system a ton of money. And so with that one person who you prevent, you may be able to afford 10 or 20 or 30 interventions. And so if if you have a false positive rate of 7 or 8 in there, it may be fine. And so what you want to do is you want to think about interventions that, and so that again, that really gets to the holistic nature of our work, which is connecting kind of medical principles with technology principles with business model innovation, which is the Hippocratic Oath, right? Do no harm. So if you have an intervention, and the Hippocratic Oath is an oath that all physicians, at least in the United States, take before they start practicing. And so if you have an intervention, let's say in a context like that, you absolutely don't want to intervene in a way that might cause someone who's depressed to do something. I'll get to you in just one moment. That psychosocial and those psychosocial metrics and dimensionalizing personality have been in the news a lot lately. They were used in the 2016 presidential campaigns in the United States to mixed results. But yeah, there is no substitute for a skillful combination of technology and an underlying theory of practice. And so, you can, if you're just a nerd, just a data scientist, you could dimensionalize users in all different kinds of ways. But if you're not working with someone who understands that specific problem, whether it's health during pregnancy or health of sobriety, then you can't think about how to do something impactful. And so that's one of the reasons why the opportunities with us are particularly interesting.
Okay, so the technology seems powerful and dangerous, and as you just said, you can extend it to other areas like politics, right? So I'd like to ask about some countermeasures, or what I mean is, you do have some moral code, as you just said, right? So what about using it with a malicious intent? Because it's basically manipulation, right?
Yeah, yeah, and there's also a really unique. So the crazy thing is that this is used, like, currently right now, this is used in all kinds of products, and the only moral code that's driving that product development is money, is profit. And so that's exactly what you see happening. So just like these, if you wanted to be critical of social media in general, you might say that people are becoming more divided, more polarized. Our news is becoming corrupted by algorithmic delivery mechanisms. So people aren't seeing ideas that challenge what they think anymore. They're seeing more and more of the same idea because the algorithm has predicted that they'll engage with that. They'll click on that. Headlines are A/B tested at a lot of newspapers now. And so that tends to make people, so I guess the counter to that is that manipulation is happening all the time. My question for you is, are you going to use those techniques in a way that are thoughtful and insightful and have a specific goal? So the other thing is that in this kind of interaction, consent is a lot different, right? So you have an individual who has said, I have a problem with drugs and alcohol in my life, right? Like, I was addicted to drugs. I worked very hard to become sober. Maybe I lost my job. Maybe I lost friends and family. And the users, the sober community is actually an amazing community. Just a level of engagement you don't see in other areas. One feature on SoberGrid is a product for musicians who travel from town to town, and there's a group on there where musicians identify other sober people in the town where they'll be playing their show. So they have someone who's because the show's often at a bar. They have someone at the bar where they're playing who also is sober. So you have this very engaged community who is self-selected to use this product. But yeah, in terms of medicine, the nice thing about medicine is that there's not only is there a professional moral code that's in place, so like the Hippocratic Oath is part of that, but there's also all kinds of regulation about how to do scientific study. So like if you're doing a scientific study, you have to have users consent. So that means presenting users with information about the kinds of science that is being performed. Do you want to participate? All of that is relevant. And so in our case, there's really interesting work in taking those principles and those moral codes that come from the tradition of medical practice in history and building them into the technology. But I guess I would say that, in my opinion, this is the perfect example of doing it in a way that is ethical. Yeah, I think fundamentally it comes down to respect for your users, right? So do I respect this user enough to tell them that I'm engaging with you on this product because I want you to stay sober, and that's why you're using this product. And so just like a user might ask their doctor for a prescription for a drug to help them improve their health, they might start to ask their doctor for a prescription to have their insurance provider pay for their subscription to this application, or something similar. But yeah, it's really complex. And that's why it's really important for any work like this to have full cross-functional teams that are holistic. I'm getting a stop sign. Does anyone want to ask one more question so we can give this mug? Yes?
Well, in order to machine learning function properly, you need to gather a lot of data. Considering that medical data is often protected by law, and this data are really volatile, so how do you handle it?
Yeah, so that's a really unique problem that's happening in the United States as well. And so there's different. So one way that you do it legally is through de-identification. So if you I don't know about Polish law, but I know in the United States, any medical data that's been de-identified, so let's say a heart surgery, and the result it was the person living 5 years later. Data sets are built like that, and you take away any identifying information and construct these data sets for research. And any medical practice is able to use those data sets for research and share those with researchers as they like, as long as the individual's data has been removed from it. But that's another whole part of our business, is how we add value to these stakeholders by protecting their data and protecting building systems that respect those laws, because that's another area where there's massive investment happening. Come to the booth later. We can talk all day about that.
Okay, thank you.